there, and welcome to the Sleepy Science Secrets. Tonight, we are going to follow something that has drifted through human imagination for centuries. Something so gentle and so strange that even scientists still speak of it with a kind of quiet wonder. Imagine standing at a window on a summer evening, the rain just beginning to soften the air outside, the distant sky flickering now and then with pale white light. And then, there, just beyond the glass, a soft glowing sphere drifts slowly past, luminous and unhurried, like a small sun that has decided to come down and rest for a moment in the world of ordinary things. This is ball lightning, a phenomenon so rare, so delicate, so strangely beautiful that for a long time people were not even sure it was real. Tonight, we will float through everything that is known and everything that is still being dreamed about. While you rest, breathe slowly and let the soft glow of this little mystery carry you gently to sleep. There is something deeply calming about the fact that not everything in nature has been fully explained yet. Some things are still open, still drifting, still glowing softly at the edges of understanding. Ball lightning is one of those things. And tonight, that mystery is your lullaby. Let yourself settle in now. Let your shoulders drop. Let the light behind your eyes grow soft and warm. We are in no hurry. This story will find you wherever you are. Regular lightning, the kind you see on a stormy night, lasts for less than a second. It is a brilliant, jagged line of light that appears and disappears so quickly that your eye barely catches it before it is gone. But ball lightning is different in almost every way. It does not rush. It does not streak across the sky in a sharp, sudden line. Instead, it forms slowly, or at least it seems to, and then it simply floats. It drifts. It takes its time. Reports from people who have seen it describe a glowing orb, sometimes as small as a marble and sometimes as large as a beach ball, moving through the air with a kind of patient, unhurried grace, as though it has nowhere particular to be and all the time in the world to get there. The colors that people describe are soft and varied, like the inside of a lamp. Some see white, some see orange or amber, some describe a pale blue-green glow, like the light at the edge of a shallow sea. Some have seen deep red or soft yellow or the faintest lavender. These colors shift and breathe as the ball moves, as though the light inside is alive in some quiet way, slowly changing its mind about what shade it wants to be. One of the most interesting things about ball lightning is how calm it seems. Witnesses almost always describe a sense of peacefulness when they see it, at least in the first moment. It does not crackle loudly. It does not make the sharp electrical snap that regular lightning makes. Instead, it sometimes produces a faint hissing sound or a very soft, low hum, barely audible above the sound of rain on a roof or wind moving through leaves. It is as though this little sphere of light is murmuring quietly to itself as it drifts along. The first written records of ball lightning go back hundreds of years. People in ancient times described glowing spheres appearing in the sky during storms, lights that moved slowly, that passed through open windows, that floated down chimneys or across the decks of ships. For a very long time, these accounts were treated with skepticism. Scientists who had never seen it themselves found it hard to imagine how a ball of glowing plasma could simply float through the air without immediately dispersing. The laws of physics, as they were understood at the time, seemed to say it simply should not be possible. But the stories kept coming from people in every country, in every century, and eventually the weight of all those careful human observations began to shift the conversation. Too many people had seen something real. If you are feeling your body growing heavier now, that is exactly right. Each breath you take is a little slower, a little quieter. The room around you is soft and still. You are floating too, just a little, just the way a ball of warm light floats through a summer storm without any hurry at all. The size of ball lightning varies enormously from one account to another. The smallest reported examples have been compared to a glowing marble or a large pearl, just a few centimeters across. The largest have been described as the size of a large balloon, or even bigger, filling a doorway with soft light. Most witnesses describe something in between, roughly the size of a grapefruit or a small melon, drifting at about waist height or a little higher, moving at roughly the speed of a slow walk. It never seems to be in a hurry. It moves the way a soap bubble moves, following the gentle currents of the air around it, pausing, turning, drifting sideways, then continuing on. One of the things that makes ball lightning so fascinating is that it can pass through solid barriers. There are dozens of accounts from people who watched a glowing sphere float right through a closed glass window, leaving the glass completely unbroken. How is this possible? No one knows for certain. Some researchers suggest that the ball may pass through microscopic gaps in the material, flowing like a very fine mist through spaces too small to see. Others suggest that the window itself may briefly become part of the phenomenon, the energy moving through it rather than around it. Whatever the explanation, the image is a beautiful one. A small glowing orb drifting quietly through glass, as though glass were simply not there, as though the ordinary rules of the material world did not quite apply to it. And perhaps that is the most poetic thing about ball lightning. It exists a little outside the ordinary world. It floats through things. It takes its time. It glows with colors that shift and breathe. It arrives during storms and then disappears again, sometimes with a soft pop, sometimes simply fading like the last light of a candle going gently out. As you breathe in right now, imagine that soft light somewhere near you, not close enough to startle, just there, floating gently in the corner of the room, glowing a warm amber or a pale, soft blue. It does not need anything from you. It is just there, and it is peaceful. And so are you. Ball lightning typically lasts much longer than regular lightning. While a normal lightning bolt is over in a fraction of a second, a ball of light may drift for several seconds, sometimes as long as a minute, and in rare accounts, even longer. The longest reported sightings describe glowing spheres that persisted for several minutes, drifting slowly through a house or across a field before quietly disappearing. Imagine several minutes of soft, floating, glowing light. It sounds less like a storm phenomenon and more like something from a slow, gentle dream. Scientists have proposed many theories to explain how ball lightning forms and what it is made of. One early idea suggested it was simply a visual phenomenon, an afterimage burned into the eye by a particularly bright lightning flash, the way a bright light leaves a ghost of itself on your vision after you look away. But this explanation was quickly set aside because too many witnesses had seen ball lightning for too long and in too many different circumstances for it to be just an afterimage. Their accounts were too detailed, too consistent, too physical. A more modern theory suggests that ball lightning is a form of plasma, a state of matter in which atoms have been energized until their electrons separate from their nuclei, creating a glowing cloud of charged particles. Regular lightning certainly creates plasma. The question is, what could make a ball of plasma hold its shape and drift slowly through the air instead of instantly dispersing? Normal plasma wants to expand and spread out. Something about ball lightning keeps it together, keeps it coherent, keeps it softly glowing in its rounded shape. If you notice your thoughts drifting right now, that is perfectly fine. Let them drift. Like that soft sphere of light, they do not need to go anywhere in particular. They can just float quietly in the warm dark behind your eyes. One theory that has gained some quiet attention in recent years comes from researchers who suggest that ball lightning might be made of microwave radiation trapped inside a bubble of plasma. The idea is this: a lightning strike can create an intense burst of microwave energy inside a small region of air. Under just the right conditions, this energy could become self-sustaining for a short time, held in place by its own electromagnetic field, glowing softly as it slowly loses energy to its surroundings. It is a beautiful idea, light holding itself in a rounded shape through the sheer force of its own field, like cupped hands holding a small, warm flame. Another theory suggests that ball lightning may be made of something very different. Not plasma at all, but tiny particles of oxidizing silicon. The idea here is that certain types of soil contain silicon compounds that can be vaporized by a lightning strike and then form a floating cloud of nanoparticles, slowly oxidizing in the air and releasing a gentle, steady glow as they do. Researchers have even managed to create a small, ball-like glow in laboratory conditions by vaporizing silicon wafers with an electrical discharge. The resulting glow did not last long, and it was tiny, but it glowed and it floated, and for a moment it was a small echo of something strange and beautiful. Laboratory recreations of possible ball lightning have been done in several countries, each one a little different, each one adding a small piece to the picture. Russian researchers, Brazilian scientists, German physicists, all have created small, glowing spheres that share at least some qualities with reported ball lightning. None of them have been perfect. None have fully captured the drifting, long-lasting, room-sized spheres that people have described encountering during storms. But each one is a step, a gentle step, toward understanding. You might like to share your thoughts in the comments tonight. Have you ever seen anything strange during a storm? A soft glow, an unexpected light? Others watching tonight would love to hear. And if this story is bringing you the rest you needed, a gentle like means the world and helps more people find their way to sleep. There is something quietly moving about the fact that so many people across so many centuries have seen the same thing. A soft glowing sphere drifting calmly through a storm, and carried that memory with them for the rest of their lives. People who saw ball lightning once almost always remembered it clearly, even decades later. They described it the way you might describe something that had briefly visited you, something soft and luminous and unhurried, and then was gone. A few people described feeling a sense of calm in its presence, a sense that everything was somehow fine. Whatever it was, it left them feeling as though they had been briefly shown something at the very edge of the ordinary world, something just beyond the reach of full explanation, glowing quietly and then gently fading. Some researchers have looked at old paintings and woodcuts to find early records of ball lightning. Medieval European manuscripts sometimes show strange glowing spheres in storm clouds. A 16th century woodcut from Germany shows a fiery ball descending from a stormy sky over a village, the villagers below watching it with expressions not of terror, but of something closer to amazement. These early images suggest that ball lightning has been part of human experience for as long as people have been standing in storms, looking up at the sky and wondering about what they see. The logs of old sailing ships contain some of the most evocative accounts of ball lightning. Sailors on long ocean voyages were especially likely to encounter it because they spent so much time on open water during storms, and open water is an excellent conductor of electricity. Ship logs from the 18th and 19th centuries describe glowing spheres drifting down from the rigging, passing slowly through the deck, hovering near the water before lifting and disappearing into the clouds above. The sailors had their own name for it. They called it a fireball, and the accounts in those logs are written in that careful, practical language that sailors used. Not frightened, not fanciful, just noting what they saw, the way a good observer notes weather or tides. Breathe out slowly now. Let your whole body be heavy and warm against whatever surface is holding you. You are safe. There is nothing here but the soft drift of a story and the quiet of the room around you. Ball lightning is not the same as St. Elmo's fire, although they are sometimes confused. St. Elmo's fire is a continuous electrical discharge that creates a glowing plasma around pointed objects. The masts of ships, the tips of aircraft wings, the horns of cattle in certain storm conditions. It is blue or violet, it crackles faintly, and it stays fixed to the object it is attached to. Ball lightning, by contrast, floats freely, is not attached to anything, moves independently, and appears in a much wider range of colors. The two are related in the sense that both are electrical phenomena of the atmosphere, but they are not the same thing, the way a river and a wave are both water, but are not the same thing. There is a particularly lovely account of ball lightning from a woman in England in the 1960s who described watching a softly glowing orange ball drift through her kitchen while she was washing dishes. She said it came in through the open window above the sink, moved slowly across the room at about eye height, passed through the closed door to the hallway, and was gone. She said she stood there for a moment, with her hands still in the warm, soapy water, just watching the space where it had been. She was not frightened, she said. She felt, if anything, a great sense of stillness, as though the world had paused for a moment to show her something quiet and unexplainable, and then quietly resumed. The science of trying to measure ball lightning is made difficult by the simple fact that it cannot be predicted or summoned. You cannot set up instruments in a field and wait for it. It arrives without announcement and leaves without trace. The only reliable records of it are human memories, and in a handful of cases, Photographs or video footage. The photographic evidence is sparse and often ambiguous, a smear of light against a dark sky that could be many things. But a few images do exist that researchers consider credible, taken by people who had no reason to fabricate anything. And these images show something roughly spherical, softly glowing, in colors that match the verbal accounts. There are also a handful of accounts from inside aircraft. Pilots and passengers have reported seeing glowing balls drifting down the aisle of a commercial flight, passing through the walls and simply disappearing. Flight crew trained to report unusual phenomena have described these events in careful, professional language. Glowing sphere, approximately 20 centimeters in diameter, amber in color, moving forward at about the speed of the aircraft's airflow, lasting approximately 8 seconds before fading. One account described a ball that bounced gently between the overhead lockers and the floor several times before quietly going out. Nothing was damaged. Nothing was burned. The passengers near it mostly sat very still and watched it, the way you might watch something passing that you instinctively understood was not harmful. If you are still listening, you might let your eyelids rest just a little more heavily now. The story is still here, drifting quietly around you, but there is no need to hold on to it. Let it just float through the soft dark of the room. One of the quieter mysteries of ball lightning is that it sometimes passes through objects without burning them or leaving a mark. But at other times, it can leave a small hole in glass or wood, or a faint scorch mark on the floor. Why this difference? No one knows for certain. Some researchers suggest that the behavior depends on the specific composition of the ball in any given case. That some ball lightning is so loosely structured that it passes through without interaction, while other instances have a slightly different energy configuration that causes a brief, localized release of heat at the point of contact. It is as though ball lightning, in all its variety, is not quite one single thing, but a family of related phenomena, sharing the same basic quality of floating light, but varying in the details of their inner structure, the way clouds vary in shape and texture, while all being made of water, vapor, and air. The relationship between ball lightning and ordinary lightning is not entirely clear. Most accounts describe ball lightning appearing during or just after a thunderstorm, rising from a lightning strike on the ground, forming near a lightning rod, or appearing in the sky close to where a bolt has just struck. This suggests that ordinary lightning provides the energy that creates or triggers the phenomenon. But exactly how that energy transforms from a fast, sharp bolt into a slow, drifting sphere is still one of the central questions. Some researchers have proposed that in rare circumstances a lightning bolt can create a self-sustaining electromagnetic vortex, a kind of energy loop that maintains itself for a short time before the energy dissipates. Others suggest it is less about the lightning strike itself and more about the specific conditions of the air in that moment. The humidity, the temperature, the particular mix of charged particles left behind after the bolt passes through. Ball lightning has been observed in many different settings: open fields, city streets, indoors and outdoors, at sea, in the air. It has been seen in tropical countries and in the far north. It has appeared in summer and winter. There does not seem to be any particular geography or climate that produces it more reliably than any other. It appears wherever there are storms and wherever there are people paying careful attention to what those storms bring. This global, borderless quality adds to its slightly otherworldly feeling. It belongs to all weather, all skies, all places where electricity moves through the air. Perhaps you would like to leave a comment about where you are listening from tonight, whether it is a warm room with rain on the window, or a quiet evening in a dry climate far from storms, or even somewhere that has seen its share of strange lights in the sky. It would be lovely to know. And the playlist of sleepy science stories is always there whenever you want another quiet evening with the gentle mysteries of the world. As the night deepens, let us think about some of the more specific measurements and observations that researchers have gathered over the years. Survey studies in which large numbers of people are asked whether they have ever seen ball lightning suggest that somewhere between 1 and 5% of the general population has had at least one encounter. This is not a tiny number. It means that in any large group of people, several will have a quiet story about a drifting sphere of light. It means ball lightning is rare, but not extraordinarily so. It moves through the world more often than you might think, touching briefly on people's lives and then departing, leaving them with a memory that tends to stay clear and precise long after other memories have blurred. Duration studies gathered from eyewitness reports and the handful of recorded instances on video suggest that the average ball of light lasts somewhere between 5 and 20 seconds, though the range spans from less than a second to several minutes. Height above the ground is typically between 1 and 2 meters, about waist to head height for a standing adult, though some accounts describe balls moving along the ground and others describe them floating high above. They tend to move at a fairly gentle horizontal speed, roughly comparable to a slow walk, though they can also hover in place for several seconds, drifting almost imperceptibly before resuming their quiet, unhurried journey. Temperature is one of the most puzzling aspects of ball lightning. Some witnesses report feeling a warmth near the ball, a radiant heat like being close to a lit candle. Others report no sensation of heat at all, even when the ball passed within arm's reach. A few accounts describe the ball feeling cool. This inconsistency is difficult to explain with any single physical model. It may again point to the possibility that ball lightning is not one single phenomenon, but a set of related phenomena with the same visual character, but different inner workings, the way different kinds of fire, a candle, a log fire, a gas flame, all produce light and heat, but through different processes and with different sensory qualities. Let your breathing be easy now, each breath a little softer than the last. You do not need to understand everything about ball lightning tonight. You do not need to understand anything. You only need to rest and breathe and let the soft image of that drifting sphere float through the gentle dark of your mind like something from a peaceful, half-remembered dream. One of the most beautiful things about studying ball lightning is the way it connects modern physics with very old human wonder. The same curiosity that led a sailor in 1750 to write carefully in his ship's log about the glowing sphere that drifted across the deck is the same curiosity that leads a physicist today to design a laboratory experiment, hoping to reproduce it. The object of that curiosity has not changed. It is still the same soft sphere, the same quiet glow, the same unhurried drift through the storm-heavy air. Only the tools for investigating it have changed, but the wonder is the same. Magnetism may play a role in ball lightning self-containment. Some researchers have proposed that the ball is a kind of magnetic bubble, a region of intense magnetic field that holds its contents together the way a soap film holds air inside a soap bubble. The magnetic field would provide a kind of elastic wall, flexible but resistant, allowing the ball to drift and to squeeze through small gaps without losing its coherence. This model fits some of the observed behaviors nicely, including the ability to pass through objects. A magnetic bubble passing through a solid object would not need to break through the material. It would simply reshape itself to flow around and through the gaps that exist at a molecular level in almost every solid material, and then reform on the other side. The idea of something reforming on the other side is a gentle one, something compressed, moving through, and then quietly expanding back into its original shape, like breathing, like sleep in a way. The slow compression of consciousness that happens as you drift towards sleep, and then the quiet expansion that comes with rest, the way your body releases its held tensions, the way your thoughts grow softer and more diffuse, the way the whole solid world becomes a little less solid as you sink into the warmth of rest. Not far from where you are right now, the air is full of invisible fields. Magnetic fields from the earth below and the atmosphere above. Electric fields that build and shift with every change in the weather. Radio waves and microwaves from countless sources, all passing through everything, through walls and glass and the soft matter of your body without you feeling a thing. The world is full of invisible movement, invisible fields, invisible energy drifting through the dark. Ball lightning may be one of the rare moments when some of that invisible energy briefly becomes visible, when it gathers itself into a small, glowing sphere, says hello in its quiet way, and then returns to the invisible world from which it came. Reports of ball lightning from inside buildings sometimes describe the ball entering through electrical outlets or light fixtures, as though it chose the path of least electrical resistance through the structure of the house. It would drift in through an outlet in one room and out through a fixture in another, following the wiring the way a river follows the valleys. This image of light choosing its own path through a house, taking the easiest route, the warmest path, the way of least resistance, feels familiar in a pleasant way. We all tend toward warmth, toward ease, toward the soft, open spaces. It is not laziness. It is simply nature finding its way gently to where it wants to be. People who have seen ball lightning close up sometimes describe a subtle smell afterward, not the sharp ozone smell of a regular lightning strike, which is more like bleach or a freshly opened dishwasher, but something softer. Some describe a faint sweetness. Some describe something more like the air before rain. A few have described a very faint smell of something burning, like a wire very gently warming. These olfactory memories are part of what makes ball lightning reports feel vivid and credible. People remember with their noses as well as their eyes, and the specificity of these smell memories adds a quality of realness to accounts that might otherwise seem too dreamlike to believe. Let yourself drift now toward the quieter shores of sleep. There is nothing you need to hold on to. The story knows where it is going, and it is going somewhere warm and still and soft. There is a school of thought that suggests ball lightning may occasionally be connected to geophysical events rather than atmospheric ones. That certain accounts of glowing balls, particularly those that rise from the ground or move along fault lines, may involve piezoelectric effects in stressed rock. When rock is compressed or fractured, in an earthquake or in the buildup to one, the crystals within it can generate brief, intense electrical fields. These fields can in turn ionize the air above the rock, creating brief glowing phenomena that rise upward. This has been seriously studied in connection with lights seen before earthquakes, the so-called earthquake lights, which share some qualities with ball lightning. If this theory has any validity, it means that the ground itself can sometimes make light. It means that light is not only a property of the sky, but occasionally a property of the earth, rising up through the stone and the soil and the grass to float for a moment above the ground before fading. The boundary between ball lightning and other atmospheric light phenomena is sometimes unclear. Aside from earthquake lights, there are also various forms of atmospheric luminescence. Lights observed near mountains, lights seen over bogs and marshes, lights reported over military ranges. Some of these are explained by known physics. Others remain in the same gentle zone of uncertainty that ball lightning inhabits. The atmosphere of the Earth is a great, complex, electrically active system, and it produces light in more ways than we have yet catalogued. Ball lightning may be one manifestation among many, one note in a larger symphony of light that the atmosphere plays in the dark. Plasma physicists who have studied ball lightning have noted that plasma in nature tends toward specific shapes when it becomes self-organizing. Round shapes, toroidal shapes like a donut, or spherical ones. This is not coincidence. When energy organizes itself in a medium, whether that medium is plasma or a fluid or a gas, it tends to form shapes that minimize surface area while maximizing internal volume. The sphere is the most efficient shape in nature, the shape that holds the most inside while exposing the least to the outside. Ball lightning, in being spherical, is simply following the most natural shape that organized energy takes. It is a sphere for the same reason a raindrop is roughly spherical, for the same reason planets and stars are spherical, because that is the shape that energy and matter prefer when they are left to find their own form. And perhaps that is something to hold gently tonight. The idea that even in the midst of a storm, even in the presence of enormous forces of energy and electricity, nature finds its way to roundness, to softness, to the gentle, closed curves of the sphere. The most violent electrical event in the atmosphere sometimes gives rise to something small and round and glowing quietly, drifting through the air with no sharp edges at all. You might want to check the playlist for more nights like this one. There are stories there about the deep ocean, about the geometry of snowflakes, about the way light bends through a raindrop to make a rainbow. All of them are waiting for you, quiet and warm, whenever you are ready for another slow drift into sleep. There have been proposals to harness something like ball lightning for practical purposes. If scientists could create and sustain a ball of plasma reliably, the applications could be significant in fusion energy research, in plasma physics, in the development of new forms of wireless energy transfer. The dream is a long way from being realized, but the dream exists, and it is a generous one. Taking something as mysterious and ephemeral as a glowing sphere drifting through a storm and somehow catching that quality, holding it steady, and using it to power things. It has the feeling of an old fairy tale, catching something magical and gentle and learning its secret name. In 2012, a team of researchers in China made an accidental observation that sent a quiet ripple through the scientific community. They had set up a spectrometer near a field in the hope of studying ordinary lightning, and their equipment captured a ball of light that drifted past at low altitude, lasting for about 1.5 seconds. The spectrometer was able to measure the composition of the light, and the results showed emissions consistent with silicon, iron, and calcium, elements found in soil. This was the first time that any physical measurement had been made of ball lightning in the wild. It supported the vaporized soil theory, or at least suggested that whatever was in that ball had been taken from the earth. The sky and the earth exchanging material in a brief, glowing sphere floating over a field in China in the summer, seen by a spectrometer that happened to be pointing in the right direction at the right moment. Science meeting mystery quietly and accidentally in a field. Imagine for a moment that you are lying in a field, not a real field, a soft, imagined one. The grass is dry and warm beneath you. The storm has passed, or perhaps it has not quite arrived yet, and the air has that charged, anticipatory quality that storms give to the atmosphere, that feeling of the world holding its breath. The sky above you is a deep, soft gray, and somewhere in the middle distance there is that slow, floating light, moving gently from left to right, amber and soft, catching no wind, casting no shadow, just drifting. You can watch it without moving. You feel no need to approach it or to understand it. It is simply there, and it is beautiful, and everything is fine. This is where science and sleep have always been closest together. In the quiet space of watching something that you do not fully understand, feeling no urgency to explain it, simply letting it be. Children do this naturally. Scientists, when they are at their best, do this too. And people drifting towards sleep do it without even trying. The mind relaxes its grip on explanation. Things are allowed to simply be as they are, glowing, drifting, warm. Most ball lightning events end quietly. The glow dims, the sphere contracts gently, and the light fades, the way a lamp fades when you slowly turn it down. This is the most common ending. No bang, no drama. Just a soft, gradual dimming, and then absence. The space where the ball was looks just like all the other space around it, as though nothing unusual had ever been there at all. A smaller number of events end with a brief pop or a faint crackling sound. Still nothing violent, still nothing alarming, just a small, sharp announcement that the ball's energy has found a final release point, and now it is done. The sound, witnesses say, is no louder than a book dropped on a table, or a door closing softly in another room. Some accounts describe the ball lightning leaving a faint residual glow behind, a dim luminescence that lasts for a few seconds in the air where the ball had been, like the afterglow of a sparkler on a summer evening. This lingering light, fading so slowly, suggests that the ball does not cease to exist all at once, but disperses gradually, its energy spreading outward into the surrounding air, spreading thinner and thinner until it becomes invisible, but perhaps not entirely absent. If there is a metaphor here, it is a generous one. Energy does not end. It only spreads and changes form. The warmth of a fire becomes the warmth of a room, becomes the warmth of the air outside, becomes part of the great invisible warmth of the atmosphere. The glow of a ball of lightning becomes the brief residual light in the air, becomes the quiet vibration of molecules, becomes part of the soft electrical hum of everything. Nothing is lost. Nothing ends. It all becomes something else, something quieter, something more diffuse, something that is everywhere at once, and therefore invisible. You are part of that too. The warmth your body is releasing right now is moving outward, gently, into the air of the room. The quiet electrical activity of your resting brain is a small and lovely thing, a field of its own, faint and soft. You are lit up in your own way, quietly, invisibly, warmly. Thank you for being here tonight. The comments and the likes and the little signs that this story found you. They mean so much. They truly do. They are what keep this channel drifting softly along, finding people in their quiet rooms at the end of their days and bringing them something gentle to float towards sleep with. The physical chemistry of ball lightning, what is actually happening at the molecular level inside one of these glowing spheres, remains one of the most actively debated questions in atmospheric physics. One of the most interesting recent proposals involves a phenomenon called non-equilibrium plasma. In ordinary plasma, all the components, the electrons, the ions, the neutral atoms, are at roughly the same temperature, and the whole thing is very hot. But in non-equilibrium plasma, the electrons are very energetic, while the heavier ions and neutral particles remain relatively cool. This kind of plasma exists in fluorescent lights, in neon signs, in the aurora borealis. It is bright without being hot in the way that a fire is hot. If ball lightning is a form of non-equilibrium plasma, it could explain why some witnesses feel no heat near it, even though it is glowing brightly. The visual brightness comes from the highly energized electrons, but the gas itself is not intensely hot. The ball glows not as fire glows, but as a neon sign glows, electrically, luminously. Without heat, you can feel from a distance. This idea changes the image slightly. The ball becomes not a little sun, but something more like a tiny floating aurora, a miniature northern lights, condensed into a sphere the size of a melon and drifting through a kitchen or down the aisle of a plane. And thinking of it that way, as an aurora in miniature, makes it feel even more beautiful, even more quietly extraordinary. The aurora borealis is one of the most breathtaking things the natural world produces. And here is something with the same fundamental physics, on a scale small enough to fit through a window, moving at the speed of a gentle breeze, glowing in colors that shift and breathe. If you have ever seen the northern lights, you may remember the feeling of watching them, that sense of silence amplified, of the universe briefly making itself visible in a particularly lovely way. And if you have not seen them, you may have seen pictures, and perhaps felt a faint echo of that feeling anyway, a resonance of wonder at something so large and soft and quietly extraordinary. That is the feeling that ball lightning seems to leave in most people who encounter it. Not fear, not confusion, a strange and quiet sense of having been briefly shown something at the edge of the ordinary. The electromagnetic theory of ball lightning, the idea that it might be a self-sustaining loop of electromagnetic radiation, has an elegant simplicity to it that appeals to physicists. Electromagnetic fields can, under specific conditions, organize themselves into stable configurations. These are called solitons, and they are found in many areas of physics and even in biology. Certain nerve impulses travel as solitons, maintaining their shape as they move through tissue, the way a ball of light maintains its shape as it moves through air. A soliton is a wave that does not spread out, that holds its form over distance, that travels intact. If ball lightning is a kind of electromagnetic soliton, it becomes part of a much larger family of self-maintaining patterns in nature, patterns that persist not because anything is holding them together from outside, but because of their own internal structure, their own perfect, quiet self-organization. Self-organization is one of the deepest and most beautiful principles in nature. It is the principle by which a snowflake becomes a snowflake. No one designs the hexagonal branching. It emerges from the physics of water molecules in cold air, each one finding its place according to simple rules that give rise to extraordinary complexity. It is the principle by which a murmuration of starlings forms its shifting, fluid shapes in the evening sky. No one bird is in charge. The shape arises from each bird following simple rules about its neighbors. And it is possibly the principle by which ball lightning holds itself together, not through any external force or container, but through the inherent self-organizing properties of the energy inside it. This is a beautiful thing to hold in your mind as you drift toward sleep. The idea that order can arise from within, that things can hold themselves together through their own inner organization without needing walls or frames or anything to keep them in shape. You are like this too, in a way. The organization of your body, the warmth of it, the rhythm of your breathing, the soft electrical patterns of your resting brain. These are not being maintained by anything outside you. They are self-organizing processes, ancient and reliable, running quietly on their own while you rest. There is a researcher named John Abrahamson from New Zealand who spent much of his career working on the vaporized silicon theory of ball lightning. He proposed that during a lightning strike, silicon dioxide in the soil is vaporized and reduced to pure silicon vapor, which then rises and oxidizes slowly in the air, producing a glowing cloud of nanoparticles. Abrahamson worked carefully, patiently, over many years, gathering accounts, designing experiments, writing papers that were sometimes accepted with interest and sometimes received with skepticism. He kept working. The patient, quiet accumulation of understanding, piece by piece, year by year, is itself a kind of beautiful process, not unlike the way a ball of light drifts through a room, unhurried, going where it goes, not forcing anything, simply moving along its own path. The scientific community as a whole has, over the past few decades, moved from skepticism toward genuine curiosity about ball lightning. The subject is now taken seriously in major physics journals. International conferences on atmospheric electricity regularly includes sessions on ball lightning. Graduate students are writing theses on it. The phenomenon has moved from the realm of folklore into the realm of legitimate scientific inquiry, carried there not by any single breakthrough, but by the sheer accumulation of consistent, credible accounts and the tantalizing partial successes of laboratory recreations. This shift from disbelief to curiosity is itself a gentle story about how science works, not a story of sudden revelation, but of gradual acceptance. The slow warming of a previously cold room, the way morning light fills a space not all at once, but incrementally. First the corners brightening, then the middle, then the whole room soft and full of day. Understanding moves like light in this way, slowly and without drama, filling in the spaces that were dark before. Let yourself be filled with that soft light now, not the light of understanding. You do not need to understand anything tonight. Just the light of warmth, of safety, of the quiet pleasure of being somewhere soft and still, while the world outside does whatever it does. Let us think about the colors one more time before we drift fully into quiet. The most commonly reported color for ball lightning is white, or a very light yellow-white, a pure, clean glow, like a small full moon. After that, the most common colors are orange and red. Blue-green is reported somewhat less frequently, and deep violet or purple least of all. The variation in color corresponds in plasma physics to variations in temperature and composition. White plasma is generally the hottest. Red and orange are somewhat cooler. Blue, interestingly, can indicate either very hot plasma or plasma with a particular chemical composition. So, blue ball lightning might be the result of specific atmospheric conditions or specific compounds in the air at that moment. But what is loveliest about the color is how it shifts. Witnesses often describe the color as not quite fixed, fading from white to orange as the ball moves, or deepening from yellow to red as it loses energy. It is a color that breathes, that moves slowly through its range, the way the sky moves through color at sunset. And like a sunset, you do not want to rush it. You just watch, and the watching is the whole point. One account from a woman in Scotland described a ball of light that was silvery white when she first saw it through her window, and had turned to a deep rose amber by the time it passed through the room and out the far door. She said it lasted perhaps 30 seconds, and she stood perfectly still for all of it, not out of fear, but out of a sense that moving might disturb it, the way you hold still when a wild animal comes very close, not out of fear, but out of respect, out of the desire to let the moment last as long as possible without interruption. This stillness that ball lightning seems to induce in people, this quiet, held breath, this suspension of ordinary movement, is one of the most consistent features of witness accounts. Something about the ball's own unhurried calm seems to enter the people watching it. The ball does not rush, and so, for those few seconds or minutes of its presence, the people around it do not rush either. They stand still, they watch, they breathe more slowly, and then it is gone, and they breathe out, and the ordinary rhythm of things returns. But something has happened that they will remember for the rest of their lives. Is that not a lovely gift? To pass briefly through someone's world, leave it entirely unharmed, induce in them a moment of perfect stillness and attention and wonder, and then quietly fade. If you could choose to move through the world like anything, there is something appealing about moving through it, like ball lightning, slowly, gently, without forcing anything, glowing in your own quiet way, and leaving people just slightly more still than you found them. Thank you for being here. Your presence in this comment section, the little notes people leave about their evenings, their thoughts, their small memories of strange lights and soft storms. Those notes are something truly special. If you have a moment before you sleep, a comment is always a welcome thing. And if this story helped you rest, a like helps others find their way here too. Some theoretical models of ball lightning suggest that the ball might be rotating. A spinning ball of plasma would have its own internal gyroscopic stability. The rotation would help keep it from dispersing the way spinning a top keeps it upright. If ball lightning rotates, it might be rotating fast enough that the rotation is not visible to the eye. It would just look like a smoothly glowing sphere, its spin invisible in the evenness of its light. But inside, at the scale of individual particles, everything would be moving, curving, spiraling in the same gentle direction, all cooperating in the quiet maintenance of the sphere. Everything in nature rotates at some scale. The Earth rotates, the solar system rotates, galaxies rotate, hurricanes and weather systems rotate, water going down a drain rotates. Even the smallest particles have a property called spin. Rotation is one of the fundamental modes of the universe, one of the ways things organize themselves in space. If ball lightning rotates, it is simply joining the largest pattern there is. The turning of everything, the great slow spin of the world. And as everything turns, you can let yourself turn a little too, settling deeper into the comfort of your resting place, turning from the day toward the night, from the waking world toward the sleeping one. The transition needs no effort. It is the most natural rotation there is. The question of why ball lightning sometimes ends with a pop and sometimes simply fades has been addressed by several theoretical models. The pop, researchers suggest, might occur when the ball's energy crosses a threshold and releases suddenly. A brief, localized burst of expansion that produces the sound. Think of it as the ball taking one last deep breath and letting it all out at once. The fading, on the other hand, might represent a more gradual energy dissipation, the ball slowly releasing its energy into the surrounding air over several seconds, quieter and quieter, until it is gone. There is something comforting about knowing that even in this mysterious phenomenon, there are at least two ways for things to end: the small, clean release of the pop and the long, slow quieting of the fade. Both are fine endings. Both leave the air clear and the world unchanged. The ball was here, and now it is not, and the space it occupied has closed gently over the absence, like water closing over a stone. Close your eyes for a moment, if they are not already closed. Let yourself be in the room completely. Feel the weight of your body. Notice the soft sounds around you, whatever they are. The breathing of the house, the quiet of the night. And in the soft field of your imagining, let that gentle sphere of light float slowly across your vision. Not too bright, not too close. Just there, amber and soft, drifting through the dark of your mind with no urgency at all. This is where you live right now, in the soft space between the waking and the sleeping worlds, in the warmth between the known and the unknown, in the place where light can be a ball and a ball can drift through glass, and everything can be mysterious and calm at the same time. One of the most interesting psychological studies done on ball lightning witnesses found that nearly all of them described the experience as distinctly calm. Even those who had initially felt a flash of alarm when the ball first appeared, because it was sudden, because it was unexpected, because storms are not always welcome, described that initial startle fading quickly into something much quieter, into watching, into a kind of absorbed stillness. The ball seemed to communicate its own calmness simply by being what it was. Something that moved without haste, that glowed without heat, that existed without demanding anything. This communication of calm through simple presence is something that the natural world does regularly if you are still enough to receive it. A candle does it. A fish moving slowly in clear water does it. Rain on a window does it. The sound of wind in trees at night does it. These things do not ask anything of you. They simply are, and their being is a kind of comfort, a reminder that the world is still here and still moving in its own way, regardless of whatever the day has held. Ball lightning belongs in that company. It is rare, and it is strange, and it is not yet explained. But it is also, by almost every account, deeply, surprisingly calm. A small globe of light, moving slowly through a stormy world, leaving everything it touches exactly as it found it, or nearly so, and then fading gently out. There are still so many questions. What holds it together? What exactly is it made of? Why does it sometimes pass through things and sometimes leave a mark? Why does it end the way it ends? Why does it appear where it appears? These questions are still open, still floating in the scientific atmosphere, the way the ball itself floats through physical air, drifting, unhurried, not yet resolved. And that is fine. That is more than fine. Open questions are the living parts of science. They are the places where the future has not yet filled in, where wonder still has room to exist, where a child watching a storm might see something that no measurement has fully captured and carry it home as a memory that lasts a lifetime. You are carrying something tonight too, not just this story, but the quiet that comes with it, the permission to not know everything, the comfort of a world that still has its mysteries, the soft warmth of a night that holds you and asks nothing in return. As you feel yourself drifting towards sleep now, if you haven't already drifted there, let the last image be that one. The ball of light glowing softly in the dark, amber and rose, small and round and perfectly self-contained. It is not in a hurry. It has nowhere to be. It drifts through the room slowly, following the air, following its own inner light. And then, gradually, gently, it dims. The amber deepens, the glow softens. The edges of the sphere become less distinct. And then it is gone. And where it was, there is only the warm, quiet dark of a room at rest. There is a kind of weather called thunder snow, where the conditions of a winter storm become intense enough to produce lightning even as snow is falling. It is one of the rarest and most quietly beautiful combinations that the atmosphere produces. A white, muffled world, the air thick with falling flakes, and somewhere in the middle of all that softness, a sudden bright pulse of light. Thunder snow creates the same electrical conditions as an ordinary summer thunderstorm, and so it is theoretically capable of producing ball lightning. No confirmed sighting of ball lightning during thundersnow has been fully documented, but researchers have noted that a glowing sphere drifting through falling snow would be a scene of extraordinary beauty. The warm amber light of the ball surrounded by the blue-gray cold of the snow, the two moving through each other like the colors of a dream. If you have ever been outside during heavy snow at night, you know the particular quietness of it, the way sound is absorbed by the flakes, the way the whole world seems to be wrapped in something soft. Ball lightning in such conditions would be so quiet, so perfectly absorbed by that silence, that you might almost mistake it for something you imagined. The way ball lightning reflects on surfaces beneath it is something that several witnesses have mentioned. Moving across the surface of water, a pond, a puddle, a flooding road, the ball casts a soft circular glow below itself, a twin of light on the water's surface, keeping perfect pace with the ball above. The reflected twin is always slightly softer, slightly more diffuse, the way any reflection is a gentler copy of the original. Two balls of light, one real and one borrowed, drifting together across the dark surface of still water. If you have ever watched a lantern or a candle reflected in a still window at night, you know this doubling, the warm original and its cooler shadow twin in the glass. Ball lightning over water doubles in just that way, and the image of it is one of the gentlest that this phenomenon offers. Physics has a concept called resonance, the tendency of a system to vibrate more easily at certain frequencies than others. A wine glass resonates at a specific frequency, and a sound at that frequency will make it ring. A bridge has a resonant frequency, and a very regular force at that frequency can make it sway. Some researchers believe that ball lightning may be a resonance phenomenon of the atmosphere, that under specific conditions of humidity and electrical charge, certain volumes of air can enter a kind of sustained resonance, a self-reinforcing vibration that produces light. The ball would then be not a thing in the air, but a state of the air itself, the way a musical note is not a thing, but a pattern of vibration in the molecules around you. You cannot hold a note in your hand, but you can hear it and feel it and be moved by it. Ball lightning in this model is something the air is doing, a song it sings briefly and then stops, leaving the air exactly as it was before the song began. Let the softness of that image settle through you now. The air around you is always just air, but it is capable of more than it usually shows. On the right night, in the right storm, it might briefly sing, it might briefly glow. And you, lying quietly in the warmth of your room, are breathing that same capable air, the air that sometimes makes light of itself. The behavior of ball lightning near metal objects is one of the more interesting threads in the research. Several accounts describe ball lightning being attracted to metallic surfaces, moving toward a wire fence, drifting along a metal railing, pausing near the leg of a cast iron stove. This attraction to metal fits naturally with theories that place ball lightning in the electromagnetic family of phenomena. Metal conducts electricity, and something that is essentially organized electrical energy might naturally find its way toward conductive surfaces. But the attraction is never violent. The ball does not rush toward the metal. It drifts gently, the way a bubble in a glass of water drifts toward the side of the glass, slowly, guided more by the subtle gradient of the force than by any dramatic pull. And then it might touch the metal briefly and leave again, or it might dissipate at the point of contact, its energy finding a path to ground and releasing quietly. Grounding, the concept from electrical engineering of providing a safe path for electrical energy to dissipate into the earth, is something that ball lightning seems sometimes to seek and sometimes to avoid. When it dissipates against a metal object connected to the ground, it is like a charge finding its natural home, completing a circuit that has been waiting to be completed. The energy moves through the metal and into the earth and becomes part of the vast, low-level electrical field of the planet itself. The earth is always electrically charged, carrying a net negative charge on its surface, and the atmosphere carries a net positive charge. Between the ground and the sky, there is a constant, gentle electrical tension, the global atmospheric electric circuit. And every storm, every lightning bolt, every ball of glowing energy is part of this larger circuit, doing its quiet work of keeping the electrical balance of the planet in equilibrium. Ball lightning, in this sense, is not an anomaly. It is just one of the more unusual and beautiful ways the planet manages its electricity. If you feel like leaving a thought in the comments tonight, even just a word about how you are feeling, that would be a lovely thing. This little channel exists because of the people who find it in quiet moments, and knowing you are here makes every story worth writing. And if tonight is your first time, the playlist is full of other gentle evenings waiting for you whenever you need them. There is a curious phenomenon called the spherics, short for spherics, or atmospherics, which refers to the electromagnetic pulses emitted by lightning. Every lightning strike sends out a burst of radio waves that travel around the earth, bouncing between the ground and the ionosphere, detectable by sensitive radio receivers thousands of kilometers away. Scientists who study ball lightning have looked at spherics data around the times and locations of ball lightning sightings, hoping to find a distinctive electromagnetic signature that could help identify what kind of lightning strike precedes a ball lightning event. The results have been intriguing, but not conclusive. There do seem to be some patterns. Certain types of lightning strikes, characterized by a particularly long current flow after the initial return stroke, seem to be more associated with ball lightning sightings than shorter, more typical strikes. A long current flow means more energy deposited in a smaller area over a longer time, more time for something unusual to organize itself in the aftermath of the bolt. The ionosphere, that layer of the upper atmosphere where the air is thin enough for molecules to be easily ionized by solar radiation, is itself a kind of vast, diffuse plasma, a faintly glowing shell of charged particles surrounding the Earth at a height of roughly 80 to 1,000 kilometers. The ionosphere is responsible for bouncing radio waves around the curve of the Earth, making long-distance radio communication possible. It shimmers with its own faint electrical life far above the clouds and storms below, and in a lovely way, it is related to ball lightning. Both are regions of plasma. Both are produced and maintained by the energy flowing between the sun and the Earth. One is enormous and ancient and permanent, wrapping the whole planet. The other is tiny and brief and strange, drifting through a kitchen for 30 seconds before quietly going out. But they are made of the same essential thing, air that has been given enough energy to become something luminous. Let your thoughts be like that right now, like the ionosphere, faint and high and spread wide, not concentrated on anything particular, just gently present. A soft luminescence at the edge of your awareness, slowly dimming as sleep rises to meet you. Ball lightning has been observed in some of the most unexpected indoor settings. There are accounts from churches, glowing balls drifting slowly down the nave, passing between the pews, rising toward the high vaulted ceilings before fading. There are accounts from hospitals, balls drifting through corridors at night, seen by nurses on the night shift, who noted them with the same careful practicality they brought to everything else. There is an account from a library where a glowing sphere reportedly moved slowly along a shelf of books, pausing now and then as though reading the spines, before turning a corner and disappearing. These indoor appearances carry a particular quality of the uncanny. The ball so out of place in these entirely human spaces, moving through rooms built for human purposes with the unhurried, purposeless calm of something that knows nothing of human purposes at all. And yet it fits somehow. A soft glow moving quietly through a library at night, between the shelves of stored knowledge and dreaming. A warm sphere drifting through a church, through the space where light has always been symbolic. These settings don't feel wrong for ball lightning. They feel, in a strange way, appropriate, as though the phenomenon belongs wherever there is a quality of stillness, wherever the air is quiet and attended to. The temperature of the air immediately surrounding ball lightning, the air just outside the sphere itself, has been a subject of considerable speculation. If the ball is very hot inside, the air around it should be heated too, and witnesses should feel significant warmth as the ball passes nearby. But most witnesses report little or no warmth, even at close range. One explanation is that the ball's outer boundary acts as an insulator, a thin layer of air that has been cooled by the evaporation of moisture, forming a kind of thermal barrier that keeps the heat inside from radiating outward quickly. This is the same principle that makes a vacuum flask work. The barrier of near-empty space between the inner and outer walls dramatically slows heat transfer. Ball lightning might carry its own insulating layer, a thin shell of cooled, denser air that rides with it as it moves, keeping its warmth private, glowing outward only with light, not with heat. Warmth that is contained, light that radiates freely. There is something almost like a metaphor for a certain kind of gentleness in that. The inner fire kept private, the outer light offered openly, the glow shared without the burn. You are warm right now too, in your own contained way. The warmth of your body, steady and private, held within the layer of your skin, your blankets, the small atmosphere of your room. The light, if there is any, is soft, and everything outside can be whatever it needs to be. You are here, held, warm, and the night is taking care of everything else. Something remarkable happens to witness perception during a ball lightning event that researchers have noted across many independent accounts. People report that during the event, those few seconds or minutes when the ball is present, time seems to slow slightly, not dramatically, not the way extreme fear can distort time, but gently. the seconds feel a little longer. Each moment of watching has a fullness to it that ordinary moments rarely have. Witnesses say they notice details they would not normally have time to notice. The exact texture of the glow, the slight fluctuation in brightness, the way the air around the ball seemed very slightly different from the air farther away. This slow time quality of the experience may partly explain why the memories are so clear and so lasting. Slowed perception means deeper encoding. The brain, presented with something so novel and so visually rich, gives it its full, unhurried attention, and the result is a memory that stays unusually crisp and complete for a lifetime. This is the gift of genuine wonder. It slows time. It deepens attention. It makes the moment feel more real, more fully inhabited than ordinary moments. And then the wonderful thing passes, and ordinary time resumes, and you carry the slow time moment with you, preserved in extraordinary detail, like a pressed flower between the pages of a book. If you ever find yourself wanting more of these slow, quiet stories, the playlist holds quite a few. Stories about the geometry of ice, about the chemistry of clouds, about the way light bends inside a single raindrop to make all the colors of a rainbow. All of them are there, waiting, warm and unhurried, like a friend who is always home. A like on tonight's video is a gentle way of saying you are here, and it helps others find their way to this quiet place too. Quantum mechanics, the physics of the very small, has been invoked in some of the more adventurous theories of ball lightning. At the quantum level, particles do not have fixed positions or definite states until they are observed or interact with something. They exist as clouds of probability spread across space, more likely to be found in some places than others. Some researchers have wondered whether ball lightning might involve quantum effects at a scale larger than quantum physics normally operates. Whether the organized structure of the ball might be stabilized by quantum coherence, the same phenomenon that makes superconductors possible at very low temperatures. In a superconductor, electrons organize themselves into pairs that move through the material without resistance, their quantum states synchronized. Something analogous operating at room temperature and in open air might, in very speculative terms, explain the ball's stability and its ability to pass through matter without interaction. This theory is considered highly speculative, even by the researchers who propose it. But speculative is not the same as impossible, and the universe has a long history of being stranger and more various than we expected. Strange and more various. The universe keeps showing us that the categories we build for understanding are always a little too small, a little too tidy. Reality keeps drifting slightly outside the edges of our boxes, glowing faintly in colors we did not quite predict, moving in ways we did not quite anticipate. Ball lightning is one of those places where reality has declined to be fully boxed. And that is not a problem. That is an invitation, an open door that the understanding has not yet walked through, a room still waiting to be entered. You might be very close to sleep now. If you are, there is nothing to do but let yourself go the rest of the way. The story will continue on its own, drifting gently through the room, needing nothing from you. If you are still half listening, that is fine too. Half listening is a lovely way to receive a story. The words drift through like weather, landing softly, leaving traces that you may or may not remember in the morning, and either way is perfectly fine. The role of water vapor in ball lightning has been examined by several researchers. Humid air with a high water content, is a better conductor of electricity than dry air, and it is also a better medium for sustaining plasma. Most ball lightning sightings occur in humid conditions during or near rain, which fits this pattern. But more interesting is the possibility that water molecules themselves might play a structural role in ball lightning. Water is an unusual molecule. It is strongly polar, meaning it has an asymmetric distribution of electrical charge, a slightly positive end and a slightly negative end. In the presence of an intense electrical field, water molecules align themselves along field lines, the way compass needles align with a magnetic field. A cloud of aligned water molecules surrounding a core of ionized air might provide an additional layer of structural stability to the ball, acting like a molecular cage that helps maintain the sphere's shape and slows its dissipation. The ball would then be partly air, partly water, partly electricity, a collaboration between three of the most fundamental and ubiquitous things in the atmosphere, briefly organized into something that glows. Collaboration is one of nature's deepest tendencies. Atoms collaborate to make molecules. Molecules collaborate to make cells. Cells collaborate to make organisms. Individual organisms collaborate to make ecosystems. And in the atmosphere, on a stormy evening, water and air and electricity occasionally collaborate to make a ball of light. The collaboration lasts only a moment. But for that moment, something is created that would not exist without all three, something that is more than the sum of its parts, something that drifts and glows and carries its brief coherence through the world before gently, inevitably returning to its components, water to water, air to air, electricity to the ground below. There are certain landscapes where ball lightning is reported slightly more often than average, near large bodies of water, near hills and ridges that disturb the flow of storm clouds, near areas where underground water changes the electrical conductivity of the soil. The coast has always been a place of elevated ball lightning accounts, which makes sense. Coastal air is humid, coastal weather is stormy, and the meeting of land and sea creates the kind of atmospheric complexity, the mixing of different temperatures and different electrical properties that might be conducive to unusual phenomena. There is a particular quality to coastal air before a storm, a density and a charge to it, a sense of accumulation. The air over a beach in the hour before a thunderstorm feels like something is being prepared, some slow gathering of forces that has been building for hours before it finally releases. And in that charged, heavy pre-storm air, walking along a shoreline as the first distant thunder sounds, the idea of a soft sphere of light drifting just above the waterline feels perfectly natural. The sea has always made its own lights, phosphorescent waves, the glow of bioluminescent plankton. And ball lightning would be just one more way that the boundary between sea and sky produces something luminous and strange. Breathe in slowly. Let the imagined smell of salt air and approaching rain come to you for a moment, if it wants to. Or let whatever smell is actually in your room come forward instead. The familiar smell of your own space, your own warmth, your own particular corner of the world. Both are good. Both are home. The research on ball lightning has produced one of science's more unusual bibliographies, a collection of papers that spans centuries, languages, and disciplines, that ranges from 18th century natural philosophy to 21st century quantum physics, that includes careful analyses of medieval manuscripts alongside cutting-edge plasma spectroscopy. Few scientific subjects can claim such a long and varied paper trail. Most new scientific questions emerge relatively recently in the era of modern instrumentation. Ball lightning is different. It has been a question for as long as people have been careful enough observers to notice that something strange was happening during storms and curious enough to write it down. The bibliography of ball lightning is, in a sense, a bibliography of human curiosity itself, the impulse to notice, to record, to wonder, and to try to understand. Nikola Tesla, that extraordinary figure at the edge of 19th and 20th century physics, who contributed so much to the understanding and practical use of electricity, reportedly experienced ball lightning himself, or at least created something like it, in his laboratory. Tesla was fascinated by high-frequency electrical phenomena, and his experiments with high-voltage alternating currents produced numerous unusual and spectacular effects. He described witnessing ball-like structures of glowing plasma in his laboratory that bore a resemblance to reports of natural ball lightning. Tesla kept many of his most unusual observations private, partly from habit and partly from a desire to protect potentially valuable discoveries. But the connection between his work and ball lightning has been noted by researchers, and some of the theories about ball lightning draw on principles that Tesla explored. The behavior of high-frequency electromagnetic fields, the conditions under which plasma can organize itself into stable structures. Tesla himself was a figure of extraordinary focus and quiet intensity, a man who worked through the night in his laboratories while the world slept, who thought in images more than in words, who described seeing complex electrical machinery in his mind before building it, fully formed, already working. The image of Tesla in his laboratory at 2 a.m, watching a small sphere of plasma drift across the room between banks of humming electrical equipment, is a scene of beautiful strangeness. A man and a mystery, alone together in a lit room while the rest of the world slept. And here you are in your own lit room, or perhaps your dark room, and the mystery is still drifting. It has not been solved in all the years between Tesla's laboratory and tonight. It is still floating, still glowing at the edges of the understood, still visiting people during storms, still leaving them with memories that stay clear for decades. And tonight, it has visited you in this gentlest of ways, a story instead of a sphere drifting through your evening as you rest. There have been a handful of attempts to use machine learning and artificial intelligence to find patterns in the large collections of ball lightning eyewitness reports that researchers have accumulated over the decades. The hope is that a system capable of analyzing thousands of accounts simultaneously might find correlations and patterns that human researchers working through the same material more slowly might miss. Early results have been interesting. The AI analyses seem to confirm some already suspected patterns. The association with humid air, the preference for appearing at low altitudes, the most common colors and durations. But they have also suggested a few less obvious patterns. Certain times of day that seem slightly more productive of sightings than others. Certain geographic terrains that appear in reports more often than their storm frequency alone would predict. None of these patterns are yet strong enough to be called conclusions. They are hints, suggestions, the kind of soft, tentative shapes that emerge from large amounts of imperfect data pointing in a direction without yet defining a destination. The imperfection of the data is itself part of the story. Human memory is imperfect. Human observation is colored by emotion and expectation, and the particular quality of attention that any given person brings to any given moment. A dataset built from human memories of rare, brief, emotionally resonant events is going to be noisy, varied, full of individual differences that have nothing to do with the phenomenon itself. And yet, precisely because of this, it is also rich. It is full of details that a measuring instrument would never capture. The smell, the feeling of time slowing, the quality of stillness that descended on the room, the way the witness stood with their hands in warm, soapy water and simply watched. These are data too, in their own way. They are data about how it feels to be in the presence of something unexplained, something beautiful and strange and calm. And that kind of data is worth something. Perhaps you would like to share in the comments what made you come to this channel tonight, or what you are hoping to dream about. The little community that gathers here is a quiet and lovely one, and your presence in it is genuinely felt. And if you have not yet explored the playlist, there are stories there waiting like rooms in a house you have not yet entered, warm, dim, full of quiet wonders. One of the most evocative threads in ball lightning research concerns accounts from mountainous regions. Mountain weather is famously electrical. The combination of rapidly changing air masses, the height of the terrain forcing warm, humid air upward quickly, and the complex terrain effects on wind and pressure all combine to make mountains some of the most storm-active places on Earth. And mountain ball lightning accounts have a particular quality. The ball appearing above a high ridge, drifting along a valley wall, rising slowly in a thermal before fading at altitude. There are accounts from the Alps and the Andes and the Himalayas, from people working in mountain huts or crossing high passes, who saw glowing spheres moving against the rock face or floating slowly over a snow-covered plateau. The image of ball lightning against a backdrop of gray stone and glacial ice and high, thin cloud has a spare, clean beauty to it. The warm glow of the sphere set against the cold geometry of rock and ice, soft against hard, briefly alive in a landscape that is otherwise indifferent to warmth. Mountain air is so clear. At high altitude, the atmosphere is thin and dry, and the light has a different quality, more direct, less filtered. Stars are brighter at altitude, colors are more vivid, and electrical phenomena are more intense. Lightning at altitude can be enormous, the whole sky filling with light in a way that lowland storms rarely achieve. In that clear, intense, high-altitude air, the conditions that make ball lightning possible might be subtly different from the conditions at sea level. The thinner air might allow plasma to organize differently. The lower air pressure might allow the ball to expand to a slightly different size or density. Mountain ball lightning, if it is indeed the same phenomenon as its lowland counterpart, might have its own character, slightly more diffuse, slightly cooler, slightly more at home in the wide, cold, brilliant air. Feel how clear the air is in your imagination right now, how high and clean and still. The mountain is dark and quiet, and the ball of light passes slowly along the ridge, amber against the dark stone, not in any hurry. Below, the valley is full of soft cloud. Above, the stars are the brightest you have ever seen them. And here, at this altitude, between the cloud and the stars, this small, warm light drifts quietly through the dark, doing whatever it is that ball lightning does, being whatever it is that ball lightning is, and then very slowly, very gently going out. Here is a small and lovely fact about the human eye that has relevance to ball lightning observation. The eye has two types of photoreceptors: cones, which detect color and work best in bright light, and rods, which are much more sensitive to low light but do not distinguish color well. In dim conditions, the eye shifts toward rod vision, and the result is that colors appear less saturated, edges appear less sharp, and the overall image is slightly softer and more diffuse. Ball lightning is often seen in the dim, gray light of storm conditions, or indoors in rooms lit only by the ball itself. In these conditions, the eye would be partly operating in rod mode, seeing the ball's glow as softer, its edges less defined, its color less saturated than it might appear in full daylight. This softness in the perception of ball lightning may contribute to its dreamlike quality in witness accounts. The eye, in low light, is already doing something a little like dreaming, blurring the edges, muting the colors, seeing the world in a mode that is closer to the way we see in sleep. Your eyes, right now, are resting. The light behind your eyelids is just the faint warmth of the room. The world is a soft blur, and somewhere in that soft blur, if you want it there, the ball of light is still drifting, amber and soft, moving without sound through the dim, quiet air of your imagining, being what it is, asking nothing, staying as long as you want it to stay, and then, when you are ready, when sleep has come all the way, going gently and completely out. The very last thing that researchers have noted, and perhaps the most tender thing, is this: that in the entire recorded history of ball lightning, centuries of accounts from every country, in every language, from sailors and farmers and scientists and children, there is not a single confirmed case of anyone being harmed by it. Some accounts mention a small mark on the floor, a faint scorch on a piece of wood, a hole in a window screen. But the people who encountered it, who stood within arm's reach of it, who watched it drift through their homes and their ships and their churches and their kitchens, none of them were hurt. Whatever ball lightning is, it moves through the human world with an extraordinary gentleness. It glows, it drifts, it takes no notice of walls or windows, and it leaves the people it encounters exactly as it found them, only slightly more still, slightly more awake to wonder, slightly more aware that the world is larger and stranger and more luminous than any ordinary day suggests. That is the gift it gives. That is what it leaves behind. Not a mark, not a scar, just the memory of a glow and the feeling that comes with it. The feeling that the world, even in the middle of a storm, even in the middle of all its noise and charge and complexity, can produce something like this, something small and round and soft, something that floats, something that glows in colors that breathe and shift, something that passes through the ordinary world, as though it knows a secret about the material of things, a secret too quiet and too gentle to be startling, but too real to be dismissed. You know that feeling now too. You have spent this time in the company of something mysterious and calm, and that is what you carry with you now into the dark of sleep. The glow, the drift, the unhurried, effortless, luminous thing that moves through the world, leaving everything a little warmer than it found it. Close your eyes all the way now. Let the last of the day release from your body. Your hands are warm and still. Your breathing is slow and deep and easy. The room around you is quiet and holds you gently. There is nothing left to do tonight, nothing left to understand or solve or remember. There is only the soft dark and the warmth, and somewhere in the imagined middle distance, growing very slowly dimmer, a ball of amber light drifting through the last of your waking thoughts, slower and slower, softer and softer, until it is just the faintest glow, and then less than that, and then the warm dark closes over it completely, and you are asleep, and everything is peaceful, and everything is well. Good night.